suppose I've got two functions, f of x and g of x, and they're both differentiable at a. Then I can define a new function, h of x, which is the sum of f and g. Right? That's a new function. To compute h of x, I just plug x into f and I plug x into g and I add together whatever f and g give me. Right? So that's a new function that I build from f and g. Now here's the conclusion, right? Then h prime of a is just the sum of the derivative of f at a and the derivative of g at a. Now to prove something like this, this is really a theorem, right? This is a theorem that tells me how to compute the derivative of a sum of functions. And how do I prove something like this? Well, I just go back to the definition of derivative, right? The derivative of this function h at the point a is the limit as x goes to a of h of x minus h of a over x minus a. Now I know what h of x is. H of x is f of x plus g of x, so I can plug that in. All right, so this is the limit as x goes to a of f of x plus g of x. And I also know what h of a is, right? I just plug in a for x, and I get that h of a is f of a plus g of a. And this is all divided by the same denominator, x minus a. Great. Now I want to calculate that limit, right? Well, I can rearrange the numerator. So the numerator is the same as what? This is f of x plus g of x minus f of a minus g of a. So I can rearrange the numerator and get f of x minus f of a plus g of x minus g of a. And this is divided by x minus a. Now what do I do? Well, I can actually split this up into two separate fractions. Right? This is f of x minus f of a over x minus a, g of x minus g of a over x minus a. So this is the limit of f of x minus f of a over x minus a plus g of x minus g of a over x minus a. And this is the limit as x goes to a. How do I calculate that limit? Right? I'm just applying these rules for calculating limits, and one of the rules for calculating limits is that the limit of the sum is the sum of the limits provided the limits exist. What are these two limits? Well, this is really the derivative of f at a, and this is really the derivative at g at a. And I assume that f and g are both differentiable at a, so those limits do exist, and I can apply the limit of the sum as the sum of the limits. So this is equal to the limit as x goes to a of f of x minus f of a over x minus a plus the limit as x goes to a of g of x minus g of a over x minus a, because I know those two limits exist. And I even know what they're equal to, right? I have a name for those two limits. This first limit is the derivative of f at a. The second limit is the derivative of g at a. So this is f prime of a plus g prime of a. And that's exactly what I wanted to show, right? I wrote down the definition of derivative of h at the point a. There it is. And I apply properties of limits until I conclude that that limit is equal to the derivative of f at a plus the derivative of g at a. Right? And this is what tells me how to calculate the derivative of a sum. Right? If I've got a sum of two functions, this is telling me that as long as those two functions are both differentiable at a, I can calculate their derivative by just adding together the derivatives of f and g. And hopefully this should seem reasonable, right? Because what is the derivative measuring, right? It's measuring how much change in the input changes the output. Right? I want to know how much wiggling the input A would affect the output of H. That's what this derivative is measuring. Right? Well, that's really going to be somehow connected to how wiggling the input to F changes F and wiggling the input to G changes G, and I'm just adding them together. So I think it makes sense that then how the output changes would just be the sum of how these two component functions change.